Yeah, just go ahead and
All right. Thank you, everyone. I'm Ben Tallman from CropX's customer experience team, also joined here by Nick Stahl, who basically runs our operations here in the US. And this webinar is going to mostly be talking about the Apex sensor in its first year. We're going to have a Q&A session at the end of this, and we'll also talk a little bit about the weather station. So, yep, you can see here contents here. So we'll start with an overview of the Apex sensor, talk about what it is, what it does. Then we're going to take a pretty deep dive into some of the data we're seeing here in the first year from that sensor and give you a chance to explore some of that yourselves. Then we'll give a brief look at the Strato, which is our weather station, and what some of that data can tell us. And then we're going to have an open Q&A at the end of this. The Q&A is not limited to the topics we're discussing here. If you have general agronomy questions, questions about things you've seen this season, or basically anything that you'd like to ask the support team, just feel free to use that. We have the Q&A turned on here in the Zoom, so you're definitely free to go ahead and use that. Or at the end, if you just raise your hand, we'll unmute you if you'd like to ask your question with your microphone. Just feel free to put those questions into the Q&A as you get them. You don't have to wait till the end for that, as members of the support team can answer those there, and then we can read those aloud at the end. So just an overview here to start with the Apex. So the Apex, this is the first year that we've commercially deployed this new sensor this season. It works with the CropX TD2 telemetry via an SDI12 connection. That TD2 is now in its fourth year of use with CropX, so many of you, even if you haven't used the Apex, are very familiar with that telemetry device itself and how it connects with various devices. The Apex is powered by a replaceable and rechargeable lithium-ion battery. And just note here, you can see the picture we have here of an Apex in the field, and you can see how that connects here with that cable. And then that is an SDI12 that would connect into the telemetry box just as any other probe you may have used with the telemetry would do. So the Apex measures everything that the V4 sensor does, and that's the percent BWC, the temperature, and EC. Something important to note here, though, with the EC is that while Sentex that we would have plugged into the TD2 would measure EC, they measured it in a different way that wouldn't work with the nutrition tab. So what's really important about the Apex is it unlocks that nutrition tab that we've had available all these years on the V4. So that's something that's very important that the Apex does for us and is something that previous SDI12 devices didn't allow us to do. It's a smooth tapered pole design. Important to emphasize the taper there. So this requires a little bit of a different auger for installation. So if you have some of the legacy Cropmetrics Sentex, those were not tapered. So the augers for those aren't ones that you would use with the Apex. As you know, we want to make sure that we use the proper auger with any sensor we're installing, as it's important to have good soil contact regardless of what tool regardless of what sensor you're using. Soil contact on installation is essential here in order to make sure you're getting valid readings that you can make agronomic decisions from. So you want to make sure that if you're using an Apex that you have that proper auger.
hey, just a small
Something that,
clarification there, Ben. It's actually just a difference in diameter where those legacy ones are smaller than the Syntex standard and the Apex. So you just yeah, it's just a difference in they're all both tapered, but just a difference in diameter.
all right. Yep. Nick's our installation guru. So any installation questions, he knows them back and front. So it is worth noting that this is fully integrated into the CropX platform. So all existing features and tools like the Insight that you've been using previously will work with the Apex. And the real important thing here, and why we have this, is we have customers who expect that a measurement every 4 inches. So just having the Apex allows us to offer our own probe on the market that gives that for the dealers and customers who do want that. It's not a replacement for the V4. If you have the V4s and you're happy with them, the V4s are great probes to have. This is just a complementary product for some customers who do want that every 4-inch measurement. So just the overview here. As mentioned already, we are looking at a measurement every 4 inches here, and we have 3 different length options currently available. The 1-foot option will measure the top 3 depths, the 4, 8, and 12 inches, and the 2-foot will measure at 6 depths, the top 24 inches, and of course the 3-foot measures 9 depths all the way down to 36 inches. So just some things to note here. The reason we have a 1-foot option here, So I'd imagine the average customer might not need them, but there are use cases for a 1 foot. For example, in parts of eastern Arkansas, you might hit a hard pan between that first and second foot. Or if you were to deploy this in Florida, you might have limestone below that first foot. Or even up in the northern plains, there's some areas where there's some uh, glacial deposits left a lot of rock material in there, and augering that second foot can be very difficult. So having a 1 foot option allows someone to go ahead and deal with some of those tougher geographic formations where installation would otherwise be very difficult. 2 foot's a great option to have because there's a lot of crops where that third foot may never actually get used with a crop. For example, if you're in soybeans, you're probably not going to see roots shoot down to that third foot. So the 2 foot's great for that. And then the third foot, of course, most of our current Centec users are using a 3 foot probe. So those of you who've used the Centec already know how you'd be using that. But it's worth noting here that the 2 foot's a good option to consider if you have been using the 3 foot. There's a lot of our Centec users end up having to use a root zone set point all year because that third foot doesn't really become applicable in all crops that they have. So just worth noting here, thinking about different length options and what might be right for you. So now we're going to start by looking at some of the data here from the first year of use here. This is just one of the profile sum graphs here. We could see that this was installed in mid-June, and we could see it came with an initial set point here, and then there was some heavy rain within those first 2 days that allowed these set points to adjust just as they would with any other probe. And we could see that those auto set points calibrated pretty well here, and set points for the last month or so have pretty much remained constant here. And we'll take some deeper looks here and see the building blocks of this profile sum here when we look at the BWC graph for this particular field. So some things I want to point out here, and actually I'm going to go back here. So this is a 36-inch sensor, and we can see that even though this is a 36-inch sensor, our full point's right around 4.5 inches. So right away, you could tell that this is a sandy field. And when we look at this percent BWC graph here, we can confirm that this is sandy. So some things we can learn right away off the bat here. While this is definitely a sandy field, the top foot has a little bit more holding capacity than the second and third foot here, just based on what's occurred in this field. We could see that the top foot holds more water and it's been using a lot more water. That's pretty much what we'd expect to see, especially on the water usage here. Now, when we look at all 9 depths together, it's sometimes hard, it looks a little cluttered here. So there are ways we can go ahead and examine what's also happening on that second and third foot here. And just note here that our y-axis here, when we're looking at the full view, goes up to around 24% BWC. So I'm going to show you here when we just look at the top. Well, first I want to show you some of the tools we have here. So again, I used the ruler tool here to go ahead and measure that initial rainfall that occurred about 2 days after installation. And that just gave us a look here to see what happened with the profile sum. So we could see here, we had a starting point of 3.59 inches, went up to 4.48 inches, and this was our delta over that 2-day rain event. And then again, just zooming in here, what's sort of interesting here is, I want you to note this rainfall was heavy enough that we had infiltration all the way down to the bottom sensor depth. So we saw a spike here. This is the 36-inch sensor here, and we saw a spike there. So worth noting here that this was a heavy enough rainfall to infiltrate all the way down to the bottom of the profile zone.
I think another cool illustration there, Ben, on that last slide, you can actually see the time delay. You know, which ones hit first versus which ones hit last, and it's from top to bottom.
Yep, exactly there. So that's really interesting. You can see the 4 and 8 here, the 12, and then it starts getting to the second and third foot down here. There is a delay there, and if you use the x-axis, you can go ahead and actually look at those exact times that it hit each depth. And actually, you can see it starts right here with the 4-inch, and then starts here with the 8, the 12, and so on. So it is pretty incredible to see that. So again, this is just looking at the top foot. So you turn off the second and third foot here by just clicking those off on the BWC graph. And you could see here that top foot had a reaction here. You could see that this was a rainfall. You could see the start and stop times of the various parts of the rainfall. As it started to peak, it would drop, then the rainfall would resume. So you could see that it wasn't a consistent nonstop rainfall. It had starts and stops there as there were breaks in the rainfall. and you could basically see the timing of those. Again, it reached the full point, and then we see the roots throughout the last month. A lot of water use here on this top foot. It's very pronounced here. We see that they're pulling a lot of water here. And also just note there's multiple rain events here. These are rain events, and then I believe these two are irrigations possibly. I'd have to look at the agenda to confirm that, but you can see multiple events here. Every event that's occurred is visible on that top foot. Now, when we look at this middle foot here, worth noting that our y-axis here is a little more condensed here. While our y-axis went up to 24 inches or 24% on the last graph, we're only down to 11.5% here, because while this whole field is sandy, this is sand that is got less clay and silt in there, so it's holding less water here. So you can see it spiked, reached its full point here, and then we could see there's some root activity here. We see that there are events here where the water does go up here. We can see that there's some other rainfall and irrigations here, but they're not as pronounced as they were on the top foot. But the water is still infiltrating here, and it is still being used here. And also worth noting, some of those irrigations at the end, we don't really see those irrigations much. You might see a little bit here where it gets a little bit flat here, where it stops using water. It wasn't stopping using water there. It's just that it was receiving enough water here to keep track with what it was using there, because we know from the previous graph that there was an irrigation on this point. So we can confirm, though, that roots are still active here, and even though there is less water there. Now, looking at the bottom foot here, this is the third foot of soil. So again, we see it spiked up here with that heavy rain that allowed us to reach our new full point that we've been working off of. And something I want to point out here, there is actually root activity here. It's not as pronounced as it is on the top 2 feet, but it is there, because we can go ahead and we can look here and see that, for example, this right here is the very bottom sensor, and we could see that we're at about 10.5% VWC. And today we've gone down to about 9.8% VWC. Again, it's not heavy water usage, but that is evidence that we do have actual root activity all the way down to 36 inches. And again, when you look at those graphs all together, you really do see that difference there in terms of how each step is using water. And in fact, if you're looking at all 9 together, this is a slope you might not necessarily see here, but when we isolate and look at this bottom foot, we could see that our more condensed y-axis lets us see that usage there. So again, just looking at all 3 feet together here, nice little screenshot here that I clipped using the compare graphs tools, where we can go ahead and put them all together. You can go ahead and see how this lines up with the profile sum in terms of that water usage there. With and again, you can see that spike, very noticeable on the top foot, less noticeable on the second and third, but it's there. But we see how water is being used across all 3 feet of our profile sum, and how water is entered there. And also, I just took here, you can ignore the emergence here. I think whoever entered in the crop information probably put that in wrong. We know emergency that occurred weeks before installation here. But you can see this is the rainfall amounts here based on the Weather Service data. And that rainfall within 48 hours of installation is what allowed us to have a pretty accurate profile sum shortly after installation. So now I'm going to go ahead here, and we're going to just look here at some of the data and just play through a video here, just demonstrating what it looks like, the click through. So again, you can pull open that profile sum with full screen as you always have. And again, you can just look at the data exactly as you would have previously with any other sensor. We can look at exact profile sum, full point, refill point at any space and time. We can click the top right, turn on the ruler tool. If we want to check what a rainfall did, we can click and drag and see that over that 10-hour period, this is our starting point, our end point, and what we added. And we can also check to see how much water we're using. So take a 2-day period. We're using about 1/10 of an inch of water per day on this field based on those measurements there. Again, we could pop open the soil moisture graph here. And again, we could turn off different depths as we did previously here. So again, if we want to look at that, just that top foot, we just turn off those different sensors you don't want to see. It adjusts the y-axis. We hone in on that top foot. Want to look at that middle foot likewise. We could turn that on and then turn off the top foot and really just get to see how we could zoom in and look at that different data. So now we're going to change gears here and go to an entirely different field here. Now this field is part of a TAPS project here. And this one is in Nebraska. Now, CropX has been participating in various TAPS programs for many years. And this time, of course, is the first year that we had the opportunity to go ahead and use the Apex for one of the TAPS programs here. Now, as demonstrated here with our summary page that we have visible here, all the features you already know are available with the Apex. Again, we have a crop status here, our moisture bar, the weather from the DTN plugin, got our CropX Insights, Profile Sum being our leading graph here, as we've not turned on root zone set points, nor do we honestly need root zone set points. When we dig in here, you'll see why. And we have the activities here as the rainfalls that have been logged in there. And our crop growth tracker is here since soybeans are the crop, and we've gone ahead and put in the crop information here. Now, this TAPS program is one where we actually have 10 different Apex probes installed on this field, each managed by a different person within that TAPS program. 5 of the Apex probes are in soybeans, which is the north half of this field, and 5 are in corn, which is the southern half. The crops were planted here on May 17th, and probes were installed on June 12th. And just an overview here, if you go ahead and if you were to look in on this, this is what the, if you click on the Fields tab and view it in the card, in the field card option, this is what you'd see there. And likewise, if you went ahead and switch it over to table view, you can see all 10 fields together here with all the information you'd expect, including the days to refill, crop information, and just everything that you would need to see here. Time of last reading, sensor, QR, all that information is available here. And actually, we're going to give you the tools to go ahead and look at this TAPS data yourself. I'll give you that a little bit later on a slide, so you can dive in to look at this yourself. But let's just look at this data first here. So in this example here, this is a 2-foot apex in a soybean field. So it's one of the, on the top half of that particular TAPS field. And we could just see how water use has changed throughout the season. So it's installed June 12th. And we could see initially that water, that root activity is just on the 4-inch probe. And in fact, then there's an event here that filled it up, a rainfall. And then it was full for a while. It started drawing down some more here. In fact, as the 4-inch drew down, it then started pulling from the 8-inch and the 12-inch and then the 16-inch. You could actually see the start dates of how these roots developed and started pulling during this period here in the later part of June. So you could just see how it started pulling. And eventually at this point here, as we get deeper into July, all 24 inches of this profile sum are showing some water usage here. And we see that stair stepping on all depths. So here's the profile sum. We already just looked at the underlying graph. I always call the VWC graph the building blocks of the profile sum. And here we could see that. So when it was just pulling from that top sensor, you could see it was bringing down the profile sum somewhat, but we were nowhere near refills. There was a lot of water in there. Then we could see when it really started pulling down on more depths, it almost hit refill here. There was a large rain event, almost got us to full, coasted down, and then this was an irrigation and this was an irrigation. So again, we could just go ahead and see how things worked here. And we'll just go ahead and walk through this, looking at each of these events and just see how water was managed here using this Apex. So I pointed out here that in early July, this field was first approaching refill when it started pulling from all depths here, but there was then a very good rainfall here. Here's from the agenda here. This is what the Weather Service said the rainfall was. And then I just looked here and you could see I went in, used the ruler tool, and this is how much water got added to the profile. We weren't at refill, we were close to it. And also, as much rain as this was, it still didn't fill the profile, but got us pretty close to full. So again, this just shows some of the advantages of sometimes not pulling that irrigation trigger too early, because let's say they'd irrigated a few days before this, while they were still in optimal, well, they might not have had room to catch all the rain, and they could have lost some of this rain and possibly even leached if they had gotten too wet there. But there was still room in the profile where no rain was lost here in this event. So then this is just the lead up here of what happened before that rain event. So this is where it was full in late June. And then we see it go down to July 3rd here. In this 8-day period, it used about 1.64 inches of water. So it's using about 20 hundredths of an inch per day, just about there, used in this period here. And again, we could see that saved irrigation here. They had not irrigated yet, and they had the room to go ahead and catch the entirety of that rain. So then here's what happened after that rain. So starting July 4th, which is the end of that rainfall, going all the way to when they irrigated. This is a 9-day period of using our starting point, our end point, our delta, using the ruler tool. We can go ahead and see they had bought themselves about 10 days there with that rainfall before they triggered an irrigation here on July 14th. So again, that apex meant that from that June 12th installation through the July 14th date, which is 32 days, there were 0 irrigation applications. And then this is just showing a little bit of a zoom out here. So you see again, this is where that first irrigation gave them some time here, and then about a week later, or a little less than a week later, second irrigation here that got them to this point here. So again, we could see that through the first 40 days here, you basically only have 2 irrigations here. And this crop's been very healthy here. We can see it's not been stressed. There's been no slowdown in water usage. It's consistently using water, and it's consistently been kept in the optimal zone without any wasting of water here. And now I just took a new screenshot here this morning here, because I built the slide deck a day or two ago, but took a screenshot here this morning to see where we were. So this is where they are right now. And we can actually see there's some rainfall in the forecast here. So it looks like normally you'd be nearing refill here. You might be thinking that you need to go ahead and hit that irrigation trigger. But right now we can see with this rainfall coming, they can actually delay that irrigation and probably aren't going to need to do so until some point next week here. So again, this rainfall is in the forecast. It's not guaranteed. So you still want to go ahead and pay attention the next 48 days to verify and see if you actually did catch that rain in the profile. But provided that you get that, further irrigation saved. And actually, right before we jumped on here, that field's west of Omaha, and this is the weather radar as about an hour ago. So it looks like they're actually going to go ahead and catch some of that rain as early as today. So they're most likely to be able to delay that irrigation until some point next week. So just to give you an idea of where you can go ahead and view this Apex data yourself, I mentioned that this is from the TAPS field. Felix went ahead and set this field up, and Felix gave me the information so I can go ahead and add it to the demo count. So we've given this demo count out before, but that username, try CropX at cropx.com, password all lowercase cropx123. And I'll show a click through on here. But again, if you want to access this, you could select the farm UNL TAPS Mead from the farm overview page, or if you go from the sensor page, if that's your preferred method of managing it, just go there and filter for Apex, and you'll go ahead, or filter for Felix's username. You'll go ahead and find these fields there, and you can explore the data yourself. It's set for viewer permission, so don't worry, you're not going to be able to mess anything up there, but you can go ahead and view that data, measure the various fields there. As mentioned, we got 10 installations of Apexes on that TAPS program. Just giving a little click through here, how you access that. So again, if you go to the sensors tab, you go ahead and just filter for grower. And then you can go ahead and look at any of these fields here. You can view them here in the sensor tab. You can always go ahead and click go to field and then load the field itself and then look at additional data. Or if you want to, you can look at table view, compare, and we also have the compare graphs tool. So if you want to go ahead and compare some of these graphs, go ahead and pull up the moisture there. So you can use that new compare graphs tool we added. We'll show also comparing the profile sums here as well. Just really can have fun here, and you could open up all 10 of these together and scroll between them if you'd like. But just gives you an ability to just cross compare multiple fields to just see how they've reacted to different events, whether it's irrigations or rainfalls, or just see how the crop is using that water. And again, just showing you how you can navigate to the field from that sensor tab. You can also navigate to the fields directly by pulling the fields tab and just filtering for Felix's username. But again, you can see we've got all the tools here, including the crop growth tracker. So now just talking a little bit about the Strato here. Strato is our weather station. This is actually the second year it's been available. What's really nice about it is that the solar panel allows us to be a permanent installation. So basically almost every Strato I could think of that was installed last year has remained installed. It wasn't extracted at, most of these weren't extracted at the end of season. People kept them in during the winter, and they've just continually left them installed. Measurements can be every 5 to 15 minutes, and that's configurable, with transmissions every 15 to 60 minutes, and that's also configurable. We're measuring a lot of variables here. We measure rainfall, temperature, wet bulb temp, the delta T, relative humidity, wind speed, wind direction, and solar radiation. And what's important here is that this device will meet the requirements for cost share programs where it is available. Some people do offer that there for their weather station. So if that's a program that's available in your area, I'd suggest looking into that with your NRCS.
Hey
And just
Ben,
show you what some, go ahead.
could you check the settings on the Q&A quick? Um,
Um,
Sound like someone was trying to. Looks like it might be closed.
let me see here. No, let me make sure here. Okay, I apologize for that. That is my bad. I just, if someone wants to send a question here, I apologize if there was an issue there. It didn't realize it had to be open there, but should be open now. So apologies there. Please do feel free to submit your questions. We do want to take those. And then I'll just showing you what some of the graphs look like when you pull open the straddle, and this is looking at it from the sensor view. Again, we can see rainfall last 24 hours, latest, last 30 days. Got temperature here, humidity, wind, radiation, and then you have totals here for the last month. If you click open, show table data, you can actually look at each day in that period. And then we've got the rainfall, temperature, humidity, all mapped out there. And I'll show a click through as well on this. And then we also display wind speed with prevailing wind direction in average wind speed in dark purple, but the max wind speeds are also tracked there in the lighter, more in the lighter shade of purple there. Got wind directions up here, radiation, ETO, wet bulb temp, and delta T. And they'll just show the click through on how this all looks together. So just again, if you are in the center tab and choose weather stations, you can go ahead and pop it open. We can see everything I showed here, the rainfall, the temperature, humidity, the wind, the radiation, evapotranspiration. That's your latest. If you pop open that show data table, you can go ahead and look at that data. What's really nice here about the show data table is there's a download button up top. So you can actually download that into an Excel spreadsheet. So if you're doing some sort of project where you need to go ahead and construct your own graphs, or if you want to cross compare multiple weather stations, using the download data feature is a great tool to have here. But you can just look at each individual day here on a graph table there, which is really nice. If you want to look at rainfall, you can go ahead and look at different forms. So you can look at cumulative, you can look at daily, and of course you can pop any of these open into a full screen view. As you could do here, temperature, it opened up here for the last week, but you can look at last month or custom date ranges or all data if you'd like to. But you can see those temperature as you go through the day-night cycle there. We got the humidity measurements there as well, the wind speed and direction, which again can be popped open there with the ability to go ahead and look at the max wind speed on any specific time, as well as the average wind speeds. You can go ahead and measure gusts and the prevailing average winds. You can also look at the prevailing wind directions on another form here using compass points here to go ahead and see what direction the wind has been blowing and how gusts have been. Got solar radiation tracked here. The ETO, the wet bulb temperature, and lastly, the delta T. And just showing you where that download option is there if you wish to download the weather data. All right, now just moving on to the questions and answers here. I see some people have already started asking questions here within the open Q&A. Again, feel free to type your questions there, or if you want to raise your hand and unmute, feel free to do so as well, and we'll answer these questions here for you. All right, Nick, got our first question here. First question here is, I have a couple of questions regarding the Apex soil sensor. How are the individual microsensors positioned within the probe to measure VWC at different depths or locations? And the second part of the question is, does the VWC sensor require calibration for different soil types? Or is it factory calibrated for universal use? So, do you want to answer that one?
Sure. Yeah, I'll take the second one first. There are no calibration needed You do not need to do anything to the sensor. Um, we are using a new type of measurement technology that we went into detail about in our during our conference. We can, send out more details on that later. But as far as the spacing, the spacing is every 4 inches um, down the length of each sensor. So whether it's an Apex 3 with 3 sensors, 6, 9, um, they're all spaced at 4 inches. So hopefully that answered that first question.
And then for the other one, the calibration question as well here, just to note that here, I just brought up a graph here to show an example. When this sensor comes out of the box and is installed here, the sensor doesn't know that this is a sand field. But what it does is it gets enough measurements here where it was able to, after that rain event, determine where the drainage stopped and where root activity began. And it calibrated here. It gave us our set points here on its own with no human input
Yeah,
within
and
48 hours of installation.
I'm always careful to differentiate between establishing field capacity at that install versus calibrating. A lot of folks always ask about calibration, and I always tell them, I said, this is not something that needs some sort of soil type input in order to actually perform the measurement properly. Either way, that install was going to measure what it measured, assuming you installed it properly. So it's just like any other type of instrument or measurement device. I always use the example of like a thermometer. If we all go to take our temperature, it's just going to tell us what that temperature is. It doesn't have to tell us that I'm taking it from my left ear or my right ear to calibrate it. So the yeah, there are no calibration um, tools, meaning you're not going to affect the way the sensor is measuring. But yes, the auto set points automatically detect where field capacity is. And I always want to differentiate that, especially for folks, that are coming from the research side. A lot of times those questions get asked.
All right. Next question here is about the wet bulb temp and how does it compare to regular temp? Uh, so that one here, actually, I can answer that one. So wet bulb temp is actually interesting here. That's basically measuring, and I apologize here. I'm reading off here just from, I'm a meteorology nerd, but wet bulb temp is something I had to actually teach myself here on this one from reading on it. So basically what it is it is measured using a thermometer with a wet cloth wrapped around it. So it's basically measuring the ability to cool depending on humidity. So for example, if there's 100% humidity, then the wet bulb temp and the dry bulb temp, which is the normal temperature reading, would be the exact same. But what happens here is with wet bulb temp, you're basically measuring the ability of air to be cooled by the evaporation of water. So that at what temperature that can occur at.
I'm totally with you, Ben. I hadn't quite understood what that was, and I think the time when it finally clicked for me was a few years ago. For those with kids or for those who've ever been involved with like high school sports, this might be a good example. But there's rules now that they can't have practices when the wet bulb temperature is above a certain threshold. And the reason is because it is exactly what Ben said. It's their ability to be able to cool themselves when they're out practicing. And so they aren't going off of just the raw temperature. It's actually the wet bulb temperature, and that threshold actually determines, how long they can practice and, if they could be outside or not and that kind of stuff. So I thought that was interesting.
All right. Next question here is what type of protocol does the Croppex Strato use? Example, is it SDI 12 like the Apex? So
Depends on the sensor. The humidity and temperature sensors are SDI 12. The rain gauge, of course, would be the pulse. And then the wind sensor is also SDI 12.
Yeah, so if you have the Strato and look at it, you'll notice that basically almost all the slots, I believe, are used right out of the box there on it. And it's with all the different tools and measurements that come pre-attached to it. Next question here is a question about the EC function here. And asking what triggers a leaching event, and then explaining the units of measurement, the DS-M, and how much that change matters, and basically just asking about how we track leaching on the probes. And Avi, let me unmute him because he's the one who can answer that one the best. Fine, there we go. Give me a second here. All right, Avi, you're unmuted here. He's from the agronomy team. He's the best one to answer this one.
Y'all can hear me? Okay, perfect.
Yep,
Okay.
we hear you loud and clear.
Okay, cool. So what EC is, electrical conductivity, it's just basically measuring the amount of salts slash nutrients that are in the soil. So it's a bulk measurement of the soil around you, and then we correct it to turn it into pore water EC. So it measures, instead of measuring the amount of nutrients and things that are electrically conductive all around you, it only looks at it, it normalizes it for the soil moisture, first of all. And so the units of decisiemens per meter, it really is very variable. But obviously, like the more nutrient load you put down, the more you'll see a spike. And I forgot there used to be like a rule of thumb, and I couldn't remember. I couldn't find it anymore after class. Um, but typically, soils that are very saline, they'll have much higher electrical conductivities than soils that just have a lot of nutrients in them. But I'm going to quickly first, I want to go to talk about leaching a little bit. So the first and foremost, the thing that triggers a leaching event is a wetting event. First of all, we have to see that in the top depth, at least, that there is a sizable increase in the soil moisture. It doesn't always have to go above field capacity, but more often than not, it does. And it has to be a large enough wetting event. But first and foremost, we have to see that within the sensor itself. We can't just use rain data. Let's say that's from a weather provider, because that it may not have rained actually on your field. And if the soil sensor didn't see it, then we can't say anything for certain. And what happens is that the moment that we detect a wetting event, what we do is we look for an appreciable drop in the electrical conductivity at the same depth. So at that top depth, at least. And then what we see is that we want to see, though, that like as the soil moisture goes up, does the EC also start to go down a little bit? And does it, when it goes down, does it stay down? Is it, because sometimes it could just be like, like a small the drying effect or something like that. So, but the most important, and it can take a day or two sometimes, because once there's a wetting event, there's a lot of things going on, and it needs to get to some sort of like stable equilibrium. So it could take a day or two, but most important thing, what we're looking for is we see a spike in the soil moisture and then a drop in the EC. And we want to see that it stays down. So that's how we detect leaching. And so sometimes people say, well, we had a really wet season and things like that. And for leaching to really occur, what we want to see, though, is that that like there's at least a certain amount that it goes down, right? It's good sometimes, people apply fertilizers and things like that, and that it may not be necessarily close to enough to the sensor for it to detect it, because for whatever reason there's an uneven spread or something like that. But we only go with what the sensor is seeing. We don't use weather data and all those other things purely by themselves to determine if there was a leaching event. So sometimes, you could say that like, oh, my whole field got really wet. But if the soil moisture sensor didn't actually experience the wetting itself, then it won't be able to see the leaching event. So that's something to bear in mind, where you want to put the soil moisture probe, because then, if you want to put it somewhere where you expect there to be more leaching, then you should put it there most likely, as opposed to, let's say, where an area that you want to have, you have different management practices, like you want to make sure it has enough irrigation. So, and sometimes those overlap, but those are not always the same hotspots within the same field. So that's something to consider. So I hope that, because I know there's a lot of questions right there. I hope that answered some of them. I can go into more detail if anyone has something more specific.
That's a very good answer there, Avi. And also, just so people know, Avi's very happy, and I'm I'm not going online here to offer this, but Avi's always happy to look at graphs with different customers here. So if you have really in-depth questions and really just want to dive into the deepest of weeds of agronomic questions, Avi has been more than happy to volunteer his time to do that.
Yeah, absolutely. I mean, and I would be more than happy to sit and go through the graphs and we could look at the raw data too. Everyone's input is super important for this sort of thing. Um, Something else I want to just mention is that the leaching algorithm itself is based off of, it's not just something like something that we, like a process model that we came up with. It's actually based off of a trial that we conducted with 25 sensors and a lot of other tag data besides, like 100 or 200 other sensors besides that, with detailed applications of different fertilizer types. So there is a real basis for the entire model itself. So but the more data you give it, obviously, the better it is. And so we're constantly trying to improve it and make it better. But at the same time, we don't want to, every single time that we see some little drop in EC at the same time as moisture, it's not always a leaching event. So it's very fine-tuned. And so it requires a lot of maintenance sometimes, but all your input is super valuable.
All right. I think that answered every question we have there. I know people always get questions as they look into this information deeper. So again, just make sure you have our contact information. Feel free to call or email support. Check out the knowledge base. Just feel free to reach out to us. We'll make a recording of this webinar available as well. So if there's anything you want to go back and watch, you'll be able to do so. And thank everyone once again for attending, and have a great rest of your day.